you, my friends? This is the basic math terms, part 18, functions in algebra course. This is the last video for the algebra terms. From next video, I will start basic math terms for pre-calculus for some videos. Then after that, it will be calculus 1 basic math terms. So in this video, part 18, we will see linear function, quadratic function, polynomial function, rational function. These are the functions we have studied in the algebra course. Then we will see what is a vertical asymptote, horizontal asymptote, and oblique asymptote. What is a hole or missing point in a graph? The zeros, domain, and range. We have seen these three words, but they are important in the functions, so that's why I mentioned them again, 9, 10, and 11. A linear function is a function that has a graph, and the form will be f of x is equal ax plus b. This we have seen in lecture number 30 of the algebra course. A linear function, when you graph it, it will be a straight line. We say linear function because the highest power here on the x is 1. Remember, there is no fractions, there is no absolute value, there is no radicals, but we can have radicals, fractions in the numbers here. Remember, a and b are real numbers. C1 over 3, this is a. Here, b is square root of 7, that's no problem. Pi here. You can have a and b any numbers. Simple, easy, positive, negative, ugly, not ugly. But x should be only x to the power 1. So the graph will be a straight line, the domain will be all real numbers, and the range will be all real numbers. This is what we call linear function. Now, quadratic function, it was mentioned in details in lecture number 34 of the algebra course. The general form will be f of x is equal ax squared plus bx plus c. So here we have squared. This is second degree, we call it second degree. So on the x we have squared. A, b, and c are real numbers. Now the shape, we call it parabola, and it will be like U-shaped. We will see now one example. Standard form, to graph this easily, you have to go to standard form. F of x is equal a, the same a, x minus h squared plus k. A is the same number here, but b and c, you cannot see them in the standard. You will see h and k. How do you find them? H and k together will make the vertex. So this is the highest point or the lowest point on the graph. We call it vertex. Okay, so h minus b over 2a, minus b over 2a, and then the k will be f of h. You replace whatever you get in the h in the function here in the general form. So this one we call it general form, this one we call it standard. Let's see a direct example on the next slide. Simple, easy example. Not easy, maybe. Let's look at this quadratic function. Minus 3x squared minus 30x minus 63. Let's find everything. Standard form, graph it, where the graph is above the x-axis, and let's call it good example. So the good example solution, just write the general form here. This is given. Let's look at the vertex. Minus b over 2a, this is h, minus b over 2a, minus 30. See, this is the minus 30, whole is b, divided by 2 times minus 3. So you cancel the minus here, divide by 3, divide by 2, you get minus 5. That's h. Now, k will be f of minus 5. You replace minus 5 inside the function here. See all this, you get 12. So minus 5 and 12 is the vertex. You see this minus 3 is negative. So this is the graph, a parabola opening downwards. So we have the maximum here. The maximum is at 12, and the highest point is minus 5 and 12. So that's the vertex. It can be the highest point. If this number is positive, only the A, guys, only the A. A is negative, we don't look at B and C. A is negative, the whole parabola will open downward. A positive, the whole parabola will open upward. So then the vertex will be the lowest point. So this is the standard now form, minus 3x plus 5 squared plus h. You can find x-intercept, put y 0. These are the numbers here in the x-intercept, minus 3 and minus 7. You can do that. And now we need where the graph is above the x. See, here is above the x there. See, above the x, we say from minus 7 open to minus 3 above the x. You can find another question where the graph is below the x-axis from minus infinity to minus 7 open, union minus 3 to infinity also open. Now, what is a polynomial function? This was in lecture 35 of the algebra course. This is a polynomial function. We have many terms. All these powers are positive integers. And that's one nice example here. If you look at 3x power 5 plus 6x power 4 minus 2x cubed plus x squared plus 7x minus 6. This is a polynomial function, all of this. And then everything you need is there, the degree, the highest power, 5. It can be there. If you have here, let's say 13, that means the degree is 13. So you look in all the terms for the highest power, the leading coefficient. This is the leading coefficient that comes with the degree. And these are the coefficients. The 3, the 6, the minus 2 is the coefficient of x cubed. Plus 1 here is the coefficient of x squared. 7 is the coefficient of x. And the constant term is minus 6. Also minus 6, we can say the coefficient of x to the power 0. Because you can write minus 6 x to the power 0. What is a rational function? This is lecture number 39 in the algebra course. And by the way, lecture 39 was the last lecture in the algebra course. Rational function, when we have a division of two polynomials here. So p of x divided by q of x. Here I put 5 examples. See, 5 over this over this, simple, complicated, different degrees, different powers. All of these are 5 examples of rational functions. A vertical asymptote. Vertical asymptote, the number, it's a vertical line here. It's an imaginary line. This is a vertical asymptote. Okay? It's a number that will make the denominator 0. So if you look at this function here, rational function, 2x plus 1 divided by x minus 3. What will make the denominator 0 here? X is equal to 3. So we say there is a vertical asymptote at 3. See, there is no graph because 3 is not in the domain of the function. If you look at another one here, 7 minus 10x divided by x squared minus 4. What will make the denominator 0? Two numbers are there, x equals 2 and x equals minus 2. Two vertical asymptotes for this one here. Okay. A horizontal asymptote. This is a horizontal line. Horizontal line, y equals something. Vertical line, x equals something. So here you look at the degree of the numerator and the denominator. If they are the same, then you take the leading coefficient of p of x over the leading coefficient of q of x. If you look at this function here, rational function, 2x squared plus 7x divided by x squared minus 4. See the same degree up and down in p of x, q of x. So you take only the leading coefficient, 2 divided by 1, which will be y equals 2. That will be the line, we call it horizontal line. Okay, you can go to lecture 39 if you need more examples in details. Also the same idea here, 3 minus 10x divided by x squared minus 1. See here we see the degree in the numerator is less. See here the highest power 1, here the highest power 2. So directly we say y equals 0 is the horizontal asymptote. Why? Because you can put here x squared, see 3 minus 10x plus 0x squared. Because 0x squared is like 0. So the coefficient of x squared will be 0 over this one here. So it will be y equals 0. Y equals 0 is the same as the x-axis. Oblique, see the word oblique asymptote. It's not easy words here. Oblique asymptote. Oblique means line which is not vertical, not horizontal. It has a slope. It's oblique. So when do we get that? If the numerator is of degree more than the denominator, like this function here, rational function x squared plus 1 divided by x minus 2. See, if the degree here is higher, 2 or 3, whatever, higher than the degree here, the degree is 1. So we divide the numerator by the denominator, and then we take only the quotient, and we neglect the remainder. That's the way here. When you divide this by this, you take the quotient. You put y equals quotient. See here, if you divide this by using long division or synthetic, you will get the quotient x plus 2. So you take y equals quotient, y equals x plus 2. That's a straight line. You see, this is the straight line here, the pink. This is straight line. That's oblique. Another word for oblique, we call it slant. So you can use both are not easy words. You can say oblique or slant asymptote, which is a straight line, not vertical, not horizontal. A hole or a missing point. This is also in lecture 39 of the algebra course. If you have a function like this, also rational function, 2x squared plus 5x minus 12 divided by x squared minus 16. We have seen this example, the same example in lecture 39. Now, if you need to graph it, first, factor up and down. Sometimes there is some cancellation. Sometimes there is no cancellation. In both cases, you have to factor up and down if you can. So here we see x plus 4, x plus 4. So we can cancel it, but there is a condition to cancel. But suppose we have down x minus 4, here we have x plus 5. We cannot cancel. We just use this function and we use the steps of graphing. Now, if you cancel here, x plus 4, x cannot be minus 4 because if you put here minus 4, it will be 0 over 0. So you have to write here, you have to mention x cannot be minus 4, which means there is a missing point or a hole in the graph. Look at the graph here, you see? There is a hole here. So anytime you make a cancellation, you have one hole. If you make 2 cancellations, 2 holes, 3 cancellations, 3 holes. You can call it also missing point of the graph. Now, we use only whatever left. We call it the new function here. If you need the y value, this is a missing point, remember? So it's a point. The x is minus 4. How about the y? Every point has x and y. So you take minus 4, you replace it. See, to find y of the missing point, replace x equals minus 4 in the new equation. 2 times minus 4 minus 3 divided by minus 4 minus 4. It will be 11 over 8. That is the point here, minus 4. See this point here? Minus 4, 11 over 8 is the y value. That will be the missing point. Now, if we need to find the zeros of a rational function, we use the same method as finding the zeros in polynomial functions, and that was in part 17 of the basic math terms. To find the zeros, put the function is equal to 0, and then you find all the values of the x. Zeros can be complex or real. Only you take the real zeros, and there will be the x-intercepts of the graph of the function. Now, the domain of a function, it was seen in basic math terms, part 12. The domain is the set of all values of x for which the expression is defined. So this is a simple example here, rational function, f of x 1 over x minus 2. See, here we cannot replace 2 in the function because we will get 1 over 0 undefined. So we say the domain is all real numbers except 2. And the range is the set of all values of y, or we call them set of images. Here we can look at this graph. The domain is this, minus 8 open to 12 closed, and the range will be from minus 4 closed to 7 closed. If you need minimum and maximum, the minimum is the smallest value in the range. Only you look at the range. And maximum is the largest value in the range. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.